Welcome to ARC301, where we talk about why modern cloud applications are so awesome.
But also whether it's more difficult to move these applications somewhere else if ever you need to do it.
So we will tackle every vendor's favorite, unfavorite topic today, and that is the topic of lock-in. First though, we should briefly explain what we mean by modern cloud applications. The graph that you will see is usually like this. Unfortunately, this graph is wrong for two reasons. The first one is that containers and serverless are not two different things. There's no contradiction. You can deploy containers on Lambda, and with ECS Fargate, you can have a serverless container runtime. And the second reason why this graph is wrong is that serverless is not just about compute, and modern applications aren't just about compute. Do you do this all manually, like ClickOps? You have no CI/CD. This is a giant monolith. It doesn't have any APIs. It's maybe written in COBOL, right? I would probably not give you the label of a modern cloud application. The reason we like modern cloud applications is because they give us some really nice benefits, right? You reduce the operational overhead and burden because we do that for you. You get higher availability and scalability of your services. You get better transparency, including cost transparency. So the definition that we like to use for modern cloud applications are those applications that fully utilize the cloud capabilities. Essentially, what we would call a cloud native application because it's native to the capabilities of the cloud.
So let's find a better definition. So modern applications are fine-grained. They give you nice abilities like failure isolation. They are also loosely coupled, which means that if you need to do a change, you don't need to drag these changes throughout the entire systems. And they are event-driven, which makes it easy to extend them. So now everybody is saying, well, very nice, sign me up. But then some questions are going to start to come. So is there any downside to that? Do I need to pay a price? And is it going to be about lock-in? And as architects, you should absolutely ask these questions.
So our job as architects is to answer these kind of questions. And as architects, we see the world as trade-offs. It's rarely the case that one thing is always right and the other thing is always wrong. So the key thing that we can do as architects is we have two very powerful maneuver to deal with these kind of questions. The first one is to see more dimensions, how we can think about the problem, and the second one is to expand the scope of the solution space that we have available. Now that might sound a tiny bit abstract, but this is exactly what we're gonna take you through. So let's talk about dimensions. The worldview that we commonly see is that folks say, well, I would love to have all the things on the right because I understand the great benefits they bring, but unfortunately there's also this thing here which we like to call lock-in. And on the other side, right, I might get freedom, but then I lose the other things. The problem with this worldview is that there is no happy place. Either I get this, but I don't feel good about that, or I could have all these great properties that I'm actually not getting. So the exercise here is not to find out where on this spectrum you should be. The exercise is to realize that this is not a one-dimensional spectrum. We can break this down into two independent dimensions. How much are you using the services? How modern is your cloud application versus how much is this lock-in thing? And so your fifth grade geometry tells you that the previous picture maps to a straight line, right? This is exactly what the previous slide showed. But by thinking in more dimensions, you can have a much more interesting conversation, like, is this actually a straight line or does this flatten out, right? Can I, push this line down and use the cloud more and keep my switching cost in check. And even more interestingly, why do there only have to be 2 dimensions? Can there be a 3rd dimension, something I haven't thought of, that I can use also to bring this entire curve down? So we see that by thinking in more dimensions, you get a very different view on this problem.
Unlocking has many different dimensions, but to be able to see those dimensions, you need to realize that nobody gets locked up. It's about switching costs, and switching costs exist in different dimensions. The first one that comes to mind is vendor lock-in. But it's not the only one. So you have product lock-in. Even if you are building your own product, if you want to move out of it, you are going to have switching costs. And then you have also version updates. You are going to have switching costs. Who is using EKS?
Okay.
Who is not on the latest version of Kubernetes? Well, and there are many reasons for that. It's not that you are lazy. No, you have to retest. You have to. You are doing something else. You have an high opportunity cost if you are doing this upgrade. And actually, we even released a feature for that. So now you have extended version support for EKS. So even for open source and for version updates, you have switching cost. And if ever you need to learn something new, well, you will have also a switching cost. So for skills, you have switching costs again. The last one, mental lock-in. So it's kind of interesting. I'm going to talk about that later on.
Great. So let's stay with the topic of dimensions, because they help us see clearly and think more clearly. So we talked about switching costs, right? There's no magic locking in, locking up here. It is about how much does it cost you to switch. Now, it's great to think about cost, but cost again is only one dimension. The other dimension is how much utility, how much benefit do you get in return of this cost. So here we have another 2-dimensional picture, and we can plot the utility against the cost, right? You have things at the bottom left is commodity. It's like a USB charger, right? It's not very differentiated, doesn't cost you much, right? You lose it, you buy a new one, right? Enough said. Top left is where we don't like to be, where something is kind of a commodity, but it's made difficult to switch. In the past, it used to be your phone providers or your mobile providers who wouldn't let you take the number. And what we learned there is that usually a competitor or maybe a regulating body steps in and often makes that go away. So that is not a long-lasting and sustainable business model. Bottom right is great, but not as frequent. To say a lot of mobile apps, social networks are like this. They're all slightly different, so I might get some unique benefit, but it's relatively easy to get rid of one and switch to another one. The interesting one, of course, is on the top right, where I have a certain switching cost and I understand that switching cost, but I get commensurate benefit against that. So I feel like my ROI, the return on lock-in, is actually very high for me. Adrian Cockcroft has a very fun and memorable way to describe that quadrant. He goes to the audience and says, well, who here is worried about lock-in? And all the hands go up. And then he says, well, who here is married? And then everybody looks at their hand and like, oh, yeah, right. So there are situations where making long-term commitments has commensurate benefits, and having a 2-dimensional model helps you think about those aspects. So what we've done here is our first architect maneuver of seeing more dimensions of switching cost, and also the dimension of cost and of benefit.
So, architect maneuver number 2 is where you make sure you don't think about the solution in a tiny box, but across the entire spectrum. And if you worked in IT, in software delivery and operations, you know this model. So we always tend to believe we have the application team. It does stuff, they implement functionality, and then they deploy. It's taken care by a operation team, an infrastructure team, and well, it kind of works. The technical term for the deployment arrow is called throwing over the wall. And then we have the other arrow on the other opposite direction, which is pass the blame if anything goes wrong. So we kind of know that this model doesn't work very well. But now the bottom layer deals with the ilities. So we have scalability, availability, reliability, and we have portability that kind of rhymes with that. But there is a fallacy to believe that, well, there are two problems with that. First, we are talking about serverless. On serverless, actually, the infrastructure, well, it's us already. And there is also the fallacy to believe that the developers, they develop their applications, and then they send that to the other layer. And then this other layer, well, they make it scale, they make it available, they make it portable. And all this after the fact, that doesn't make any sense. So the second important lesson here is that you shouldn't try to solve a problem in the other layer. You should try to solve the problem in the layer where it originates, because this is the best lever you have to find the solution. So let's talk about 5 approaches you can use. 2 we believe doesn't work terribly well, and 3 that works quite nicely. So when the topic of switching costs comes up, and generally it's a conversation with procurement, and it's a traditional IT vendor selection, and the conversation goes like this. So we have these cloud vendors. How different can they be? So one has a virtual machine, while the other one probably has a virtual machine service. One has a database, a message queue, even a serverless function service. So when you look for far enough, all these clouds look the same. And actually, I look like Gregor.
Well,
but here...
you need to look from very far.
But it's not the exercise, and you need to zoom out. So let's zoom out, and let's have a look at our database services. We have many databases. We have time series, graph, relational, NoSQL, all kind of possible databases. What are the odds that the other vendor has exactly the same portfolio? Very low. And it's good that cloud vendors are not carbon copies. They have different philosophies, they have different architecture, they have different implementations, and it's good for you because it gives you choice. So now let's have a look at EventBridge. EventBridge, very simple service, core to serverless for event-driven applications. It's not the most complex service. You push an event, you filter, you route it somewhere else. Kind of easy service. But when you list the characteristic right from the documentations, well, it's already all this. And this service doesn't live in isolation. This service is integrated with IAM, CloudWatch, CloudTrail. So the odds that it's going to map with the other cloud vendor are really low. Sorry. Sorry.
Right.
So, on some vendors, actually, they use these maps. They like to use these maps, these comparisons. We don't do that at AWS because we don't believe it really brings much value. It's kind of, well, would it be so nice if it were working? But actually, it is not.
Good. And with that, we come to the second approach. And this approach is so common that it actually has been termed the universal theorem of software engineering by Andrew Koenig. And that is, can we solve everything by adding one more layer? And we have living proof that this works. So let's say we have different teams, and different teams prefer different programming languages. As architects, we know how we can accommodate that. We accommodate that by putting a common layer on top, right? You fix the protocol, you say this is HTTPS, OAuth, JSON, whatever have you, and now you are able to hide this diversity under a common layer. The way I describe that is you gain some options. You gain the option to have different languages by giving up other options, right? You're giving up diversity in your integration protocol, you harmonize that, and in return, you gain diversity. Very powerful architect maneuver, and we know that this works. So the idea is not far-fetched to say, well, can I do the same thing over different cloud platforms, right? I just put this common layer on top, and I only need to learn this one layer, and I don't need to deal with all the details underneath. I call this the Esperanto effect. The idea is very nice. Yeah, wouldn't it be nice if we all spoke the same language? We wouldn't have to learn these languages and have dictionaries and translators and all these kind of things if we all spoke Esperanto. Now the reality is very few of us do, because in the end we all speak English. We're both not native speakers, but close enough, right? It works. So this extra layer idea sounds good, but in reality it's hard to do. And one of the reasons it's hard to do is, Jean-Francois already said, right? The clouds are not carbon copies of each other. The feature sets are different. So one way you can go about it, you fill in the gap. Now, however, that is not so easy. So I speak from experience. I actually did quite some porting of serverless solutions, and I realized, for example, that DynamoDB has atomic appends and the other database didn't. I cannot go and add atomic appends to another cloud service. I had to rewrite my application. I used composite keys in the end to do that, right? But it wasn't something that I could add to the service. And even if I did, there's reInvent, and it happens every year, and every year we announce over 3,000 new features and services. So this is a moving target. The alternative, of course, isn't that great either, because you take the lowest common denominator. So there are features that we might have that you are not using, and that is putting you at a disadvantage. I call this the grim wrapper. It seems so tempting to want to wrap these things, but once you do, you're burdened with all these kind of things. And we haven't even talked about that this service isn't just like a functional set, it's also scalability, billing models, integration with security schemes, IAM, etc. Right? There's a lot more things that you would need to tackle.
And there is another reason why this doesn't work. And that is that logical abstraction cannot abstract physical properties. So let's take the example of this startup. They built a serverless application for their business. And then they ported it to AWS. And then they realized, well, it took them only 2 weeks. So kind of easy. And all the problems they had to deal with, no abstraction layer would have been able to help with that. It's all these things, so pricing model. What if one price the service via invocation and the other one by runtime? We improve the scale-up of serverless functions, of Lambda. We improve the throughput of SQS. So it's scaling targets that are moving. No abstraction layer are going to help you with that. Same thing with latency. Then there are things that tend to be different, like retrial logic, time to live. So on the last one, so the second unfavorite topic of the cloud vendors, service availability. So what if the service you want to use on the other vendor is not available on this region? You cannot do anything with an abstraction layer. Now we talked about options. And it has been proven mathematically options are always valuable. So never tell anybody, well, don't worry about that. But the downside, well, an option has a cost. you are going to provide some efforts to build these things that you are missing for the portability. And it's something that the developers, they won't do something else, so you pay in opportunity cost. On this opportunity cost is it's a decent multiple of the daily rate of the developer if you have a good running business. So pay attention to your math here. But the worst part, I mean, the one which is going to haunt you is complexity. Because when you reach a high level of complexity, bringing that down, actually you can spend a lot of money on that. Finally, Gregor already talked about that. If you lower the bar, so well, you are moving in the wrong direction on this quadrant, so you are reducing the utility, and it's not so nice.
Yeah, be very careful if you compromise the utility in benefit of something else. The two-dimensional matrix makes that very easy for you to see. So as speakers, we have a little bit of a bragging contest. And that is about making laws. Like you guys probably know Conway's Law, there's Postel's Law. Now the nice thing is that there's no governing body on these kind of laws that we make. So I made my own law. And that is Gregor's Law, because I wasn't so creative with the name, but the content is something that I saw from many customers. Having options is nice. But if you want all the options all the time, if you're not willing to make any decision, you want this at any scale, in any language, in any color, on any platform, in any country, the price you pay is complexity. Right? And as Jean-Francois already said, complexity is a tricky one. For money, there's a bank where you can put it and take more out of. For complexity, there's no place where you can go and deposit that. So be careful, right? Having options is nice. Having all the options all the time comes at a high price, and that price is excessive complexity. So let's stick with the options a little bit. We both worked in the financial services sector, so we know options very well. So what we can do is, we talked about switching cost, and mapping an architecture problem to a money topic is a very clever thing to do, because everybody knows about money. It's easy to talk to decision makers and executives, and there's a lot of good theory behind money. People get Nobel Prizes in economics for these kind of things. So let's do this a little bit mathematical. So I carry a liability. I have built something, and if I want to move that something somewhere else, that's gonna cost me money, or even upgrade the version, right? That's gonna cost me money. What is the likelihood that I need to do this? So let's say you have a serverless app and you say, well, it cost me like 100 grand to port this to somewhere else, right? It's a reasonable amount of money, and maybe I have a 2% chance that I need to do that. I carry a 2,000 euro or $2,000 liability, right? The probability that this happens times the price that I need to pay if it does happen. Now, what you don't want to do is invest $50,000 to reduce this $2,000 liability into $1,000, right? It's not very good math. So the exercise is not to drive this thing to the furthest possible, right? To bring the switching cost down to the lowest possible. Your exercise is to minimize the total cost, right? The sum of how much do I need to invest to push this down versus how much does this actually go down. And you will find that the optimum there is not on the outer ends. The extrema are rarely the optimum. The optimum is going to be somewhere in the middle. And financial services folks will know this extremely well. This is the price you pay for the option, and this is the strike price that you pay when you exercise the option, when you actually move. So you translated this mysterium of lock-in into a very rational financial model where you can now have a discussion about, of course, let's not be naive, right? Let's not paint ourselves in a corner, but also don't be overinsured, right? There is somewhere a middle ground here, and that is where you want to be. Since we talked about how nice it is to map things to money, is today's money is more expensive than tomorrow's money, right? Discounting rates, inflation, right? We all know this. So be careful, the upfront cost, this investment, this is in today's money versus this liability, this might come in like 2 years or 5 years, that is in tomorrow's money. So this is actually not one for $1. You paying a higher price now than you get the return in the future. You can see this most dramatically with very fast moving company, right? If you are a startup company and you spend 6 months building a portability framework, you're out of business. The cost is infinite, right? You have nothing else. So what we see because of that is that the fast moving companies are much more likely to choose one solution, run with it, get customer success, and celebrate the success. Remember the utility axis. They want to optimize or maximize utility because the opportunity cost of building something else is way too high. Now, interestingly, I see a lot of large companies who do want to build such layers and frameworks. The catch there is, the reason those companies go to the cloud is because they want to be agile and fast-moving and high velocity. They want to be like these fast-moving companies. But they make decisions like an old company, right? They say, oh, our opportunity cost is not so high. We can wait 6 months. We can wait a year. So the problem is, if you want to transform, you need to think like the people you want to transform to, not like the people where you're coming from, because that transformation will not actually work. So mapping this to money is a very nice way to understand where on this spectrum I should choose and how much of a layer I should be building or not.
So there is a common counterexample to that. So SQL, isn't it available on all relational databases? So kind of portable. But it's good to read on history here. SQL was not built for portability. There was this first company, so they wanted to make relational database easy to use, and they developed SQL. And then the second company started to copy that. Well, it's pretty nifty. Let's do that. And then, well, yeah. But even if we look at SQL, it's not the most complex language, but they stopped to publish the documentation in one single book. So even for that, it's kind of complex to do it. And don't forget, SQL, so it's the logical abstraction layer, but it doesn't abstract the physical thing. So if you need to tune on the relational database, you still have to do that. SQL is not going to help you with that. So SQL is a good example. It's a productivity tool which became portable, interesting. And this is a big pitch here. You need to start with productivity. Because if you are not productive and your competitor is, well, the problem of portability is not going to come to you. And it's bad for your business. It means you are in a pretty bad situation. And well, now I'm a huge fan of open source. And open source, very often, they tend to lead as saying, well, we are portable. We make it easy for you to move from one place to another. However, well, there is probably a better pitch. They make you productive. Why do you use open source software? They make you productive. You can see you can maybe comment, drive the roadmap of the open source project. So they make you more productive. And if ever you need to move somewhere else, well, it gives you your utility part, plus it keeps in check the switching cost. So very nice. So now we promised 5 approaches. And we are finished with the bad news, then starts the good news.
Number 3.
With fully managed open source. So no wonder that AWS gives you a number of services, a number of open source software that we manage. And if we look at nearly all categories, it can be databases, message queue, monitoring, we have open source managed services for you. So please use them. It's a good thing. And we highly recommend, but it doesn't always work. There is little open source service for things like that heavily rely on large-scale operations like serverless, so Lambda, Event Bridge, step function. What do you do in this case?
So we mentioned the second most important architect maneuver was to broaden the solution space. And in this case, we do that again by looking at more dimensions. We hinted at this third dimension, this magic Z factor. Is there another dial that we can turn? Is there another lever we can pull that impacts the ratio between utility and switching costs? And the answer is yes, we can. And that factor is velocity. And that is your velocity. It's independent of the services you use. It is how well oiled your software delivery machine is. And I have many examples of this out of my past. Many years ago, old JDKs, I think it was like 1.6 or so, went out of support and had some exploits. So basically mandate, you need to get off JDK 1.6. One of the switching cost dimensions Jean-Francois talks about, version upgrades. I know organizations who had like year-long plans and programs and probably spent like 7-digit amounts in the end to get this done. And if you have a small, nimble, fast-moving company, they probably did this over the last weekend and they didn't even notice because they were on 1.8 already anyhow. They're using the same product. There's nothing wrong with this product. The switching cost that they face is orders of magnitude different because of the way they're working. And it's not about sort of passing the buck, right? It's about expanding the solution space. There are other dials that you can turn, and velocity is a very powerful dial to reduce switching costs. Remember the startup example, the 2 weeks, they could do this because they had high levels of automation, right? They had a clean architecture, they knew what they were building, managed their dependencies, they were running a lean ship, and that's why they could port their application in 2 weeks. Their switching cost was low because their velocity was high. Now, there's many talks about how you increase your velocity, right? There's well-known strategies, high levels of automation, reducing friction, reducing software inventory, right? These long-running feature branches that are still around after 6 months, they're probably not perfect about improving your velocity. And then the last one always sounds a little bit clever, right? Don't build things that don't have value. It's like, well, how do you know which ones have value? Well, the answer is you do that in an agile way. You make small iterations, you see what works and what doesn't work. So these are the well-known methods that we use. This is DevOps, this is lean methods, and these are agile methods. So our architect maneuver here led us to a very important insight that switching costs isn't just a function of the services you use, but it's also very much a function of how you work, and that is a fantastic lever that you can pull, because increasing your velocity helps you today because it makes you more productive, but it also reduces the switching cost if you ever have a switching scenario. And that brings us to the last one we have. So we promised 3 good news. And remember, I mentioned mental lock-in on the switching cost. So let's go back to our favorite service, so EventBridge. I put that on my diagram on my architecture, but it doesn't tell me your intent. So I don't know. On EventBridge, you can do many different things. So you are going to filter message, you are going to route them to different, depending on the content, you are going to transform the messages, and you are going to send them to different recipients. If you give me only the icon, I'm losing that. On where am I going to find this intent? I need to look into the code, and it's probably lost. So keep the intent. So the right side, it was what you decided to do, but the right side was what you wanted to do, and the left side was the ultimate implementation. So you need to maintain that intent on what is a relation with switching cost. If ever you need to move somewhere else, I will get an example. So we've seen EventBridge does different things. Let's say the other one has a different service for filtering on recipient list. So if you don't know the intent,
well, I don't know where I'm going to migrate, where I'm going to move. So that was no, yeah. So yeah, go.
This was the last one you had.
Yeah,
you had hinted earlier. We talked about mental lock-in, right? So
yeah. So if you keep the patterns, you are going to keep the intent, and it will help you to switch to another place.
Yeah, and the way we like to say this, and this comes from a vendor, right? We love our services, but if you only think in one vendor's services, you are mentally locked in. You will have a harder time expressing what you did or remembering what you did and expressing that with another provider. So this is a very subtle but very dangerous form of lock-in. I'll give you a concrete example. So these are some of the 20-year-old patterns. I wrote a book 20 years ago about integration patterns, and these examples are still very relevant. So let's say I built a very nice distributed serverless application, and this is called a scatter-gather. I need to send some messages to other people, and then I need to re-aggregate. I need to summarize the responses. Like, I want the car insurance quote, right? Who's giving me the best quote? Everybody give me an answer, and then the portal can show what that best answer is. Happens all the time. Very, very common use case. Now, what are some of the decisions that you need to make to build this? Well, there is a relatively long list. The first one is, do you know who the recipients are and how many they are, and do they come and go? Like, does this number vary? Are they required to respond? This is very important for your design, because if you know how many recipients there are and they're required to respond, you know how many responses you get back. If you don't know that, then you cannot rely on the number of responses. So you need to decide what your completeness condition is. Like, when do you know that you're done collecting answers? Is this a timeout? I wait 2 seconds. Do I wait for 3 answers? Can I qualify the answer so that this answer is good enough that I don't need to look for others? If I time out, is this absolute or incremental from the last one I received? A lot of choices you can make here. Once you know you're done, you have more choices. Do I just concatenate the answers? Do I show the best answer, or do I somehow mathematically aggregate them? So there's a lot of design decisions. 2 very important learnings here. The first one is, none of this is in the service icon, right? This is the architect work. That's what you guys are there for. The service icon, like Jean-Francois said, that's the final decision. But maintain these decisions and the trade-offs, right? Otherwise, you have the mental lock-in. The second advantage that this has is that these are conversations you can have with a broad set of audience. You can go to your business users and say, hey, do they need to respond? How often do the recipients change? What is the maximum number? Do I have 0, right? These are easy conversations to have. If you go there and say, hey, can you help me edit, the EventBridge filter expression? They're probably going to say that is a little bit difficult. So the second major advantage you have here is by disassociating the design decisions from the service selection, you can invite a much broader audience into this conversation. So the learning here is that by just picking the service, you might be overlooking your most important design decisions. The service selection is only one piece, and you will make many other decisions along the way. And as Jean-Francois highlighted, capturing those also reduces your switching costs, because you maintain the intent. That is a recipient list. So for a recipient list, I need that service, versus for filter, I need that service. So you maintain that knowledge. So it's easier to map. And quite honestly, if you need to start over or change something, you have a much, much better starting point. And I speak from experience here because I did this myself. I built a sample application very much like this, and I built it serverless native the way it should be, and then I ported it. And I found out that I had a very good starting point because I had maintained my design decisions and my design intent.
So where are we? So the powerful maneuver that we did is that we didn't shy away from the topic. You should worry about it, but you shouldn't fear it. You should reframe the problem by understanding that nobody gets locked up. It's about switching cost. And then these dimensions help us as well. So it's the utility versus the cost, and the different dimensions of switching cost. And then the option theory. So it's not about bringing the strike price to zero, it's about minimizing that total cost and understanding that today's investment is more expensive than future payoff. So that was a powerful maneuver that got us from fear-mongering to the other extreme, ignorance into a sensible conversation.
Correct. And then we looked at 5 different approaches, right? We said 2 that are commonly seen, but they have some critical nuances, right? Service mappings look nice on paper. In reality, the clouds are not carbon copies, and you don't want them to be carbon copies. And then abstraction layers can work, but chasing the innovation rate of multiple cloud providers with an abstraction layer is a tricky undertaking, and you pay a high price, a high opportunity cost for that. So then we saw 3 methods that actually do work. Open source is an easy one, right? Managed open source, you get low switching costs, but you also get high utility. We broadened the horizon and said this is not just about the services you pick, this is also very much about how you work. And then last we saw thinking in patterns and design intent, not just services, also helps you reduce the switching cost.
Hold on, Gregor. So we spent 45 minutes to basically tell people, well, they should do good software development, they should do good architecture, use the design pattern, use high velocity. Is that the message?
Yeah, basically, if you're running a lean ship, if you do good software development, right? You have high velocity, you use open source, you use managed service, you have CI/CD, you have automation, you understand the patterns. Switching cost is unlikely to be your biggest problem. So the short answer is yes, focus on delivering software in high quality, quickly, and with good development discipline today. And that is actually the best mechanism that you have to also bring your switching costs back down, because if the day ever comes, then you are well prepared. And that is exactly what you said at the beginning. Don't solve this problem somewhere else. Solve this problem where it originates. So these are software engineering solutions to the topic of switching costs. So if you use these levers, then you're well prepared for the switching cost scenario, as opposed to expecting some infrastructure team to do that for you. And with that, we're at the end. If you like this kind of way of thinking, we both actually like to write books where we don't talk about, well, actually we talk about lock-in a tiny bit, but we talk about cloud and different aspects of cloud strategy, and we talk a lot about platforms. So we always invite you to have a look, and please reach out, right? We are quite active on social media. So if you have any questions or comments, right, connect to us, and we'll be happy to have a chat. With that, thank you very much.
Thank you.